these two problems here are both rational functions. Also, if you plug them in, you'd also notice they were both of the indeterminate form. If you plugged in x equals 0, we get an indeterminate form for h. If you plug in x equals 0, you get an indeterminate form for p. So let's deal with these one at a time. So let's take the 9x over x squared and numerically look at finding the limit. So we're going to start a tenth away, and then 100th away, and then 1,000th away. And then we're going to do that on the other side, a tenth away, 100th away, and 1,000th away. So if I plug into this function, negative 0.1, I get a negative 90. If I plug into this function, negative 0.01, I get a negative 900. If I plug in negative 0.001, I get negative 9,000. The output does not exist if the input is 0. Now, if I do a positive 0.1 and plug that in, I get a positive 90. If I do a positive 0.01 and plug that in, I should get a 900. If I do a positive 0.001 and plug that in, I should get 9,000. So from left to right, from underneath, we're getting negative numbers, but they're all getting bigger. From right to left, as you're getting closer to 0 from above, you are getting positive numbers that are all getting bigger. And therefore, this limit does not exist. Okay? So that 0 in the denominator, the rational function, this one became, again, this one had the indeterminate form of 0 over 0. The previous example had 5 over 0 as its form. That's not an indeterminate form, but that's another type of form that causes us trouble. But this one did have a 0 over 0 indeterminate form. And it ended up with the limit not existing. Now let's take a look at the next example. So the next example is x squared minus 2x divided by x to the third plus 5x. Again, we're going to be trying to estimate as we get towards 0. Numerically, we're going to do this. We're going to fill out a table and then plug those things in. If I plug in negative 0.1, I get a negative 0.4191617. If I plug in a negative 0.01, I get negative 0.4019992. If I plug in a negative 0.001, I end up with negative 0.4001999. Obviously, plugging in 0 doesn't work, doesn't help me. If you plug in a positive 0.1, you should get negative 0.3792415. If you plug in a positive 0.01, you get negative 0.3979992. And if you plug in 0.001, you end up with negative 0.3997999. So you can see that the trend there, even though this function does not exist when x is equal to 0, the output does not exist when x is 0, we still get that this function is converging towards a negative 0.4 as x gets closer and closer and closer to 0. Now, let's look at both of these graphically and see what we can do. So let's start with the 9x over x squared. So take 9x over x squared. And let's look at what's happening as x is tending towards 0. So on the right-hand side, as x goes from right to left and we tend towards 0, notice this is shooting off into the stars. And on the left-hand side, as we go from left to right, notice this is shooting out or shooting down into the ground, right? And so since these things aren't going towards the same, since these pieces aren't going towards the same point, we say the limit does not exist when x is equal to 0. Now the other function was y equals p equals fraction x squared minus 2x divided by x to the third plus 5x. If you zoom in on this, as x is going towards 0, even though it doesn't work when you plug in a 0, as x is going towards 0 from right to left, it is going to this point here. And if you zoom in far enough, you'd catch that it is negative 0.4. And from left to right, you zoom in enough, you catch that, yeah, that's negative 0.4, which we're traveling towards. So as x is going towards 0 from right to left and from left to right, we're going towards negative 0.4. We have a lot of different interesting things that can happen. The book also gets into a concept called the difference quotient. We're not going to do that on this section. We will get to that in some sections later. That is going to end it for our looking at section 1.1.